Okay, welcome back to General Maths Foundation 2, and we're starting the linear modelling unit. So just to start off, the first thing we're going to cover is what we call directed numbers, and it's essentially just dealing with negative numbers. Most of the way through people's maths learning, for example, let's just say we have 3 plus 2. We have numbers, we have operations, and what we're not used to is just the assumption that the numbers that we plug in either side of an operation, we're just used to always assuming that they're positive numbers, because until this thing is taught in high school, negative numbers are a bit of a secret. I don't know why they hide that stuff away. But from now on, we need to get used to dealing with negative numbers. So the first thing we're going to look at is what happens when we have two signs together in an addition or subtraction. So essentially, let's write it up here. So we can have, there's a few different possible ways around they can go. We can have a positive, let's use 5. We can have two negatives together, or we can have a positive and a negative, or a negative and a positive. So this is just a little table. Okay, so in the table, when we have two signs together like this, we can combine them into just one sign, or we can turn it, the operation and the sign, into just an operation, and then think about what happens to the number. So a hard and fast rule is when we have two signs the same, so a positive and a positive, or a negative and a negative, we always end up with a positive number. So let's just write positive 5, positive 5. But when we have a positive and a negative together, or a negative and a positive, these give a negative. So really, it's just sort of simplifying when we have two signs together. And when we're adding a negative number or subtracting a positive number, we can think of the sign as the operation and the number as a positive in the way that we're used to thinking of it. You just have to do quite a few and get used to them. So here's the first example. We'll just jump straight in, and it's simplifying when we have two signs together. So we've got a few different ways of writing them. This is B 1.1. 2. Negative equals. So we've got two examples that have brackets involved. These ones don't. So you can sort of put brackets around anything really. It just sort of groups things together. Quite often when we have this sort of situation, it helps to separate when we have an operation and a number with a particular sign that might be different. So just using these conventions, so all we're really looking for is, are the two signs different or are they the same? And if they're the same, it's one of these cases and we end up with a positive number. If they're different, we get a negative number. So here we've got a negative and a positive. So this is negative 52. Let's just do that so that they're separate. Or if this came in the latter part of an equation, then this would be the same as saying subtracting positive 52. But for now, we're just looking at combining two signs down into one. So here again, we've got a positive and a negative. So this is simplified negative 13. Here we've got a negative and a negative inside the brackets attached to this 25. So it's sort of like saying the opposite of a negative. So that's this case, and that is essentially, I'm just going to write 25. In general mathematical notation, because positive numbers are the things we normally deal with, we sometimes don't write the plus sign in front of the number. I mean, I'll put it in now. But if you don't see a sign in front of the number, then assume that it's positive. And because of this case here, if we're just subtracting a positive number, sometimes you can think of it as adding a negative. These are essentially equivalent, the same. But we'll get into that in a little while. Okay, so here again we've got two signs the same. So this is positive 3. And that's it. So as far as just simplifying when we have two signs together, if they're the same, we get a positive number. If they're different, we get a negative number. Right, so I'll leave that there for now. So now we're just going to look at adding and subtracting negative numbers. So let's write these out first. So this is V1.2, and we have 6, 8. Let's write them down this way. 3, 7, 8 plus negative 2, 14 plus negative 20. Okay, so the easiest way to think about these is if we have a number line. So I'll just quickly do that. 0 in the middle. 1, 2, 3. And we keep going. Oh, that's hiding in behind. And in this direction we have negative 1, 2, 3. And that keeps going in that direction. So the important thing, actually I'll make 0 in red just so we can see where the middle is. So we've got our positive direction, our negative direction going that way. So the idea is we're quite happy working in the positive end of the scale. For example, 2, let's just say 2 plus 3, we would start at 2 and we would jump 3 spaces and we'd end up at 5. 2 plus 3 is 5. Nothing special there. But what we have to get used to is the fact that sometimes we're going to end up, or we'll be starting down here in the negative. Just spotted a little mistake there. 5, 6, 7. I'm glad I spotted that before I got too far. Right, so let's have a look at these. So we've got 6 with nothing in front of it, so really that's a positive. Positive 6. And here's our operation. So really this is, we're taking away positive 8. So it's kind of like this. So we won't attach a sign to the 8 for now. But essentially what we do is we start at 6. Because we're subtracting, I sort of like to think of actually standing on the line and walking up and down. So I'm either walking this way or I'm walking that way in the positive direction. So when we get to the operation, this is the first number is the place we start. The operation is the direction we face. And then the sign of the number that we're adding or taking away is how many steps we take. The number is how many steps, but the sign determines whether we walk forwards or backwards. So really, this is it. This is like we start at 6, we face the negative direction, so we're facing this way, and because we're taking away positive 8, we take 8 steps forward. So we're going this direction because we're subtracting 2, 3, 4, 5, 6, 7, 8, and we end up at -2. Because imagine if we started at 6, if we take these 8 away one at a time, first of all we take the first 6 away and we get to 0. 6, take away 6, and then there's still 2 more to take away. It's one way of thinking out of it. So this will give us -2. I'm trying to be very careful referring to these numbers negative and positive, not to get confused with the addition and subtraction that use the same symbol, but there is a strong relationship between them. Okay, so let's just rub out that little bouncy thing. Okay, so the next one, -3 plus 7. So this is plus, we can think of that as +7. So I'll just put that little plus in there. So this is really this is a case like this. So really we're just going back to +7, +7. So in this case we start at -3. Because we're adding, we would be facing the positive direction, and we're adding a positive number, so we walk forward in this direction. So we start at 3 and jump 7 spaces in the positive direction. 1, 2, 3, 4, 5, 6, 7, and we end up at +4. So to write it like that, just for now, I'm going to put that positive out the front. Okay, the next one, I'm going to rub that out. So really, using this sort of thing that we were doing before, this 8 plus -2, because we're a plus and a negative together, is really, we could write this as 8 take away 2. So thinking of the 8 and 2 as positive now, but our operation is subtract instead of adding a negative. We're essentially swapping to this where we're subtracting a positive, because these, like I said, are the same. But just reading this, we would start at 8. We're facing in the positive direction, so we're facing this way. But because we're adding a negative number, we would take 2 steps backwards. So we'd start at 8. We go 2 steps in that direction. 1, 2. And we end up at 6. Positive 6. Okay, so let's look at this last one. 14, and that is a positive 14. And we're adding negative 20. So in the same way, we could think of this as 14 subtract positive 20. So we'd start out at 14, right out here beyond the end of where I've made it to 10. And because this is the same as subtracting 14, take away positive 20 because of this interchangeability. So essentially, if we started at 14, if we take away 14 of these 20 just separately, after we take away 14, we'd end up back at 0. But there would still be 6 more. So we'd start out at 14, we'd go 20 jumps this way, and we'd end up over here at negative 6. Hopefully that makes sense. I might just chuck another one in, just to sort of show why 2 negatives essentially give us a positive. So let's just try, we'll start at 2 and we'll take away negative 3. Let's try that one. So like I said before, this is the number where we start, so we'd come to 2. Because the operation is negative, we would then face this direction. But because the number that we're taking away is negative, we take 3 steps backwards. 1, 2, 3, and we end up at 5. So when we take away a negative, we move in a positive direction. And that's why we end up with positive 5. Hopefully that makes sense. Just takes a bit of practice, a bit of getting used to. So really it's a extension to the operations we're used to doing with positive numbers, but we're also allowing for negative numbers to exist in our calculations. Okay, so that's for addition and subtraction. When we come to multiplication and division, it's slightly different. So we'll get rid of this number line. Get rid of these. So I'll write the rules here. It's kind of similar. So this is for multiplying. So this is add and subtract. When we multiply or divide, it's kind of very similar. When we multiply 2 numbers or divide two numbers, treat the 2 numbers as positive numbers, multiply them together, and then depending on what the 2 signs were and how they combine, tells us what sign the final answer actually is. So when we multiply a positive, I'm going to write the operation in blue, times the positive, we get, and I'll put this in red, a positive answer. When we multiply a negative, and a negative. Let's put the multiply in there. So this goes for divide as well. I'm just using multiply. It sort of works out the same. We also get a positive. Let's just put a little box around that. Now, when we multiply or divide two numbers that are different signs, kind of like this, when we get two different signs together, we end up with a negative. So positive times a negative, or a negative times a positive. Oops. A positive. Swapping textures, let's put this times in the middle. Equals. We end up with a negative answer. So I know I've written times here, multiply, but it also goes for divide. So when we multiply or divide two numbers with different signs, opposite signs, our answer will be negative. So we treat the numbers in the same way that we would for positive multiplication. This sort of case, this is what we're used to doing, to take two positive numbers, multiply them together. So we're really looking to see if the signs match, then we get a positive. If they're different, we get a negative. And so we've got to be careful, because sometimes the operation in front of a number, as long as you're comfortable jumping between these, when we see subtracting a number, really you need to think of that as it's a negative number. But that will come up. That will come up. Okay, so I've got a few more examples here from the book. This is 1.3 now. So we've got, I'll write these down the page again. -4 times 5, -3 times -6, 12 divided by -3, -14 by -2. Okay, so we'll just talk through the logic behind it. So we've got, so really this 5, because we don't have a sign written, is a sneaky plus. It's a positive number. So what we do is we just ignore the signs at the start. We multiply the two numbers as if they're positive, and then depending on whether the signs match or if they're different, that will determine what the sign is. So 5 times 4 is 20. But because we have a negative times a positive, they're different, so we're going to end up with a negative result. So -4 times +5 is -20. The next one, I'm ignoring the signs for now. 3 times 6, 3 6s are 18. And then because it's a negative times a negative and they match, this is +18. We normally wouldn't write that, but just for the purposes of distinguishing between negatives and positives, I'm going to put it in there for now. Okay, here again, we've got 12 divided by -3. So this 12 is a sneaky positive, and we haven't written it in because we just need you to assume that numbers that don't have a sign are positive. So 12 divided by 3 is 4. I can do that in my head. And we've got a positive divided by a negative, positive and negative. So our final answer is negative. And finally, 14, -14 divided by -2. We could write this as 2. It's sort of the same, writing it as a fraction. So 14 divided by 2 is 7, and because we've got a negative divided by a negative and they match, this is going to give us a positive result, positive 7. So again, kind of there is a similarity. When the signs match, we get a positive answer. When the signs are different, we get a negative. But it's slightly different way to combine them. Okay, so I've got a few more examples. So this is still the same. I might write these going down as well. 6 times -2 plus -5 times -2. So there's a bit of BODMAS, BIDMAS, PEMDAS, PEMA, whichever one you learnt. When I was at school, we didn't have that special name for doing this. We just called it order of operations, and we learnt the order that you do things in. Maybe I'll just do these one at a time. Okay, so first of all, we've got some brackets. We've got a plus here. The negatives here are signs that are attaching to the numbers they're in front of, but we have to understand what the operations are. So that's a times, that's a plus, that's a times, but those ones are the signs in front of the numbers. This is why it can sort of be confusing. Okay, so although we have brackets, we really should do the multiply, both this multiply and that multiply, before we add anything together. Right, so we'll do this one first. 6 times 2 is 12. This 6 doesn't have a sign, so that means it's positive. A positive times a negative gives us a negative number. Now we carry our operation down, plus, and inside the brackets here we have -5 times -2. So 2 times 5 is 10, and the two operations are the same. So we're going to end up with, and I'll keep it inside brackets, positive 10. So we can do the thing that we did up here. So really, two positives together means we're just adding, starting at -12, and we're adding 10. This equals -2. Hope that makes sense. Okay, I'll leave that one there while we do write out the next one. Oh no, we'll do both of these together because they're very similar looking. 6 times bracket 3 plus -7. And I'll write the other one, 6 times 3 plus -7. So I'm hoping you can see that these are very similar looking. The only difference is we've got brackets around this bit here, and we don't have the brackets for this one. So BODMAS, BIDMAS, whatever you say, would tell us that we have to do what's inside the brackets before multiplying. Whereas in this one, we're going to multiply before we do this bit. So over here, I'm just going to rewrite that 6 times, and we'll see what we get here. So we're starting at +3, where this is a situation like this. So we're essentially starting at 3, and we're taking away 7. So we're going to end up at -4, and then 6 times negative 4, so don't forget this is positive 6. So 6 fours, I should put an equals there, 24, and a positive times a negative gives us a negative answer. Okay, hopefully we're all good with that. Okay, so over here, because we don't have the brackets, it means we do this bit first, multiply first, and then we add the negative 7. So 3 times 6 is 18, and this is a positive, and that's a positive, so this is still positive. I won't write it in, I'll just leave it like that. But then we have to add negative 7. So like we did before, adding a negative is kind of the same as subtracting a positive. This is like 18 take away 7, and that equals 11. So notice how having the brackets here and then the brackets not being there is given us two very different answers. That's kind of the reason when you see things like this on Facebook, you have long lists of people arguing about what the answer is. Because some people, they forget the order that things should be worked out in. They tend to want to just work things out left to right. And usually there'll be additions at the start, multiplications or divisions later on, and people get confused about the order they should do stuff. That's kind of why that happens. Okay, so that's where I'm going to leave this video. Hopefully, after you've had a bit of practice, you'll get used to when the signs match, we get positive. Same here. When we add a positive or we subtract a negative, it's kind of like we're adding a positive number. When the signs are different, when we're adding a negative or subtracting a positive, it's kind of like subtracting a positive number. When we multiply two numbers with the same sign, our answer will be positive. When we multiply or divide two numbers with different signs, our answer is going to be negative. Oh, I've been sitting in front of that the whole time, haven't I? Okay, that's where I'm going to leave it.